Hi, my name is Carl Basdio. I'm a chemical engineering undergraduate at the University of Connecticut, and my topic is carbon nanotubes, separation and structures. The AI key article chosen was conical carbon nanotube arrays, large area synthesis, electrochemical and field emission characteristics. In this presentation, I will discuss what carbon nanotubes are, how they are made, the properties that make them so valuable, and the applications in which we could use carbon nanotubes. What are carbon nanotubes? Carbon means fullerene, or a molecule that consists only of carbon. Nano comes from the fact that the diameter is only from 10 nanometers to 100 nanometers. Basically, a carbon nanotube is a sheet of graphite rolled into a cylinder. There are generally two types of carbon nanotubes, a single-walled and multi-walled. Multi-walled consists of layers of carbon nanotubes within each other. Within the two types of carbon nanotubes, there are three subtypes: zigzag, chiral, and armchair. These differ by the way the sheet of carbon is rolled into a cylinder. Zigzag means horizontal, chiral means diagonal, and armchair means vertical. The way the carbons are oriented in these three types grants different properties to the carbon nanotubes. Carbon nanotubes are made in one of three ways: arc discharge, laser ablation, or chemical vapor deposition. Arc discharge is probably the most common and easiest method used in creating carbon nanotubes. Within a high temperature container, two graphite rods, one negative and one positive, are set a small distance apart from each other. A charge is sent from the positive rod to the negative rod, vaporizing the graphite on the negative rod, which then immediately sublimes to create different types of carbon nanotubes. The downside to this process is that the carbon nanotubes are often very difficult to separate and purify, and they are often very tangled with each other. Also, a small amount of product is made. Laser ablation involves using a laser to vaporize graphite at high temperature. The vapor then sublimates on a cold surface, creating nanotubes. The downside to this process is that the nanotubes that are created are usually tangled with each other. There are also many different types of nanotubes produced, and a small amount of product. The process that has the greatest potential of being used commercially is chemical vapor deposition. It requires a metal catalyst made of nickel or cobalt. The chamber needs to be heated to about 700 to 1000 degrees Celsius. The process is initiated by adding hydrogen gas or ammonia along with a carbon-containing gas such as methane or ethylene. The downsides to this process is that mostly single-walled nanotubes are created. Also, it's a difficult task to remove the nanotubes from the catalyst. The most attractive property of carbon nanotubes is its strength. It is the strongest material discovered so far in terms of ability to stretch and to resist breaking. It's 4 times more elastic than Kevlar, which is the material used in bulletproof vests, and 5 times lighter than steel. Although it's very strong, it does not withstand bending, twisting, or compression forces, due to the fact that it has a hollow center and very thin walls. The single-walled have a higher elasticity, while the multi-walled have a higher ability to resist breaking due to the many layers. Structural applications for carbon nanotubes could include replacing Kevlar in clothes, armor, or other fibers. Also, combining carbon nanotubes with other materials such as concrete or polymers could help it resist cracks from water or tears from wear. Carbon nanotube flywheels will also spin at very high speeds without shattering, allowing us to store massive amounts of energy. Due to the light weight of carbon nanotubes, sports equipment could be made lighter but more durable. The uses for carbon nanotubes in separation include using it as a filter. The hollow tube allows only small molecules to pass through, while leaving the larger ones outside. It could be used as a filter for smokestacks, or a fast, low research water filter for contaminated water or salt water. The diameter of the nanotubes could be customized depending on the process used to produce the nanotubes. They could also be used as a transport biological molecules due to their small size. In conclusion, carbon nanotubes are cylindrical sheets of graphite that are very strong and durable material. They have the potential to improve many of the tools we use today, or create new ones in the future. But in order for this to happen, we would need to improve the synthesis methods used to make carbon nanotubes, making them more efficient and less expensive.